This problem is kind of nice because we get to review exponentials again. We have e to the x to the fourth plus 5. So we have x cubed, that's not really being manipulated, but x to the fourth plus 5 is because it's being raised from a base e. So u is back to being up in our exponent. So we want to remember our goals with exponents look a little bit different because we have two different exponential rules. If we have something that looks like e to the x, that antiderivative is e to the x plus c, versus if it has a different base like 2 to the x, then the antiderivative is 2 to the x over ln of 2 plus c. So it just depends upon our base which rule we're going to use for this. But we know u is going to be the exponent. And in this case, it's raised from a base e, which is really nice because I think that antiderivative is just a little bit easier than if it was a 2 to the u instead of an e to the u. So we're going to keep this in mind, but first we're just going to write down what u is. It's x to the fourth plus 5. And the derivative of that, du dx, derivative of x to the fourth is 4x cubed, derivative of 5 is 0. And then we'll just multiply by dx. So now we have our u and our du. And we're on to the toughest step. We need to figure out this substitution. So first thing, figuring out what's happening to u, it is e raised to the u. X to the fourth plus 5 isn't raised to like the 10th power, so it's not u to the 10th. It is the power, so it's from base e. So it's e to the u instead of u to a number, like a lot of them have been. So we are good to go with that part. We have accounted for this whole thing as just being e to the u, and everything left over, we want to account for it by writing a big du in there. So we need a 4, an x cubed, and a dx. We have an x cubed, we have a dx, but we are missing a 4, which is fine. We can account for being off by a constant. So one way of saying it is we have x cubed dx, so it's 1/4 of what we need for a du. It doesn't have a 4 in there, so it's 1/4 of what we wanted. So we put a 1/4 outside and a du inside. That is one way, and it is totally fine. If that makes sense to you, I would use that method. Another way is visually putting a 4 in there. We're missing a 4. I'm just going to pop it in there so that I can see that I have 4x cubed dx, exactly what I need. 4x cubed dx. But I can't just do that because it allows me to write a du. It'll make my answer 4 times too big. So to account for that, I put the reciprocal outside, I put a 1/4. So if we were missing a 7 on the inside, I put a 1/7 outside. If we have a 1/10 to put it on the inside, I'd put a 10 on the outside. You just flip it and put it outside. However you want to get to it. It was 1/4 of what we needed for our du though. So we're going to keep that 1/4 and we're going to integrate, and it's going to look like this part of the goal. The antiderivative of e to the x is e to the x plus c, so the antiderivative of e to the u is e to the u plus k. And our last step is just going to be replacing this back for x's and plus c's. So I'm going to replace my u in the exponent with that x to the fourth plus 5. So our antiderivative is 1/4 e to the x to the fourth plus 5 plus c.